Okay, in this question, we have a discrete probability distribution. The question is about a local animal shelter that adopts out cats and dogs each week with the following probabilities. So, for example, they will get 5 cats or dogs with per week with a probability of 25% or 0.25, or 3 dogs or cats per week or each week with a probability of 15%. Yes, so the question is to find the mean, the variance, and the standard deviation for the number of animals adopted each week. So of course you have to use this discrete probability distribution table. So anyways, watch this. I'm going to copy it on the next page. Okay, but I'm going to do something a little different because we need to do the mean, the variance, and standard deviation. So here, I remind you of the formulas for the mean, for the variance, and for the standard deviation. Remember that it's very easy to get the standard deviation once you get the variance, because you just take the square root. So anyways, the table, as you can see, that we have underneath, the first 2 rows are exactly what we had here, this table. I just copied it there. But then you add a row for the product of x and px, because when you compute the mean, this is what you're doing. You're multiplying each x by its probability, plus the second x by its probability, plus, and so on until you reach the last one. So what we're going to do now is multiply each one of these x's, the first x by its probability, then the second x by its probability, then the third x by its probability, and so on. So 3 times, okay, let's do it like this. 3 times 0.15, if you multiply it, you get 0.45. So I'm going to just say here 0.45. If you do the second one, 4 times 0.3, you'll get 1.2. If you do 5 times 0.25, you'll get, of course, 1.25. And if you multiply 6 with 0.2, you'll get 1.2. And last one, if you multiply 7 by 0.1, then you'll get 0.7. Now, you need to compute the total. It means add up all of these numbers that you had in this row. And guess what this would give you? If you add up all these numbers, you'll get exactly the mean. This is the formula for the mean, which you add up all these numbers. Or you can abbreviate it like this. It's the sum of all x times px. So anyways, the number that you get here is 4.8. Well, let me instead write it with the same color, 4.8, same color as the borders. So remember that this is also our mean mu. So we have computed the mean. We can say here, therefore, the mean for this data is mu, which is 4.8. Okay, now the second thing that you have to do is to complete the this row, x squared times p of x. So it's exactly the same as the one before, except that you do x squared. So instead of 3, you'll do 3 squared, which is 9. Instead of 4, you'll do 4 squared, which is 16. And then 5 squared, which is 25. And then you multiply the 9 by its probability, the 16 by the probability, the 25 by the probability, and so on. You do the same for the 5 numbers. So I'm going to erase this, and now let's start. I will remind you, you square this and then you multiply it by this. So 9 times 0.15, you'll get 1.35. Okay? And then you do 4 squared times 0.3, you'll get 4.8. Then you'll do 5 square it times 0.25, you'll get 6.25. Then you'll do 6 squared times 0.2, and this will give you 7.2. And last one is 7 squared times 0.1, which will give you 4.9. And you just compute the total here, you'll get 24.5. But this number 24.5 is just the sum of the squares of the x's times the probability of x. But for the variance, if you look at the variance up, it is this total that you just computed, and you subtract from it minus the square of the mean. So therefore you can say the variance that we call sigma square is equal to the total that we found here, which is 24.5 minus mu squared. Mu is the mean, which we computed here, or you can see it up here. So minus 4.8 squared. And if you do this on your calculator, you should get 1.46. And this becomes the variance. And the last one, you can say now, therefore, the standard deviation, that's the easiest one to compute now. The standard deviation is just the square root of the variance, which we just computed. So it's the square root of sigma square, which is the square root of 1.46, and this would give you approximately 1.21. So this becomes our standard deviation here. And this finishes the problem. So what do we need to know? You need to know just these three formulas. Those three. You don't need to memorize at least the standard deviation, no memorization, because if you know the variance already, you just take its square root. Just remember, when you make this table, I believe that the table makes it easier for you to do this question. But if you don't want to do the table, you can apply the formulas directly. That probably will take, for some people it might take a shorter amount of time, for some people longer, but really having this table here is very nice. I would say here, this is nice to have for solving any problem related to finding the mean, variance, and standard deviation for discrete probability distributions. And this finishes this question.